Hi guys, this is a video following up from our measurement lesson where we were measuring the sides and angles of right angled triangles, and we did some calculations and found some common ratios. So what we're going to do in this video is formalize what we learnt and work through a formula that we can use to calculate angles and sides in right angled triangles. So we're going to use this right angled triangle here, and I'm going to label this angle here in the corner with a theta. Generally with trig we use Greek letters to label the angles, and we use our normal alphabet to label the sides. So if you don't see a theta, some other common ones you might see are an alpha or a beta or a gamma. It's usually going to be one of those four. So once we know which angle we've got, we need to label the three sides. And unlike Pythagoras, how we label the three sides is actually really important. Okay, we know the hypotenuse from Pythagoras, that's always opposite the right angle there. And then we've got the two shorter sides, which we're going to label with O and A. So to determine which one is O and which one is A, we look at the angle that we're given. So in this case we're looking at this angle here. So opposite this angle is our O. So that will be this one, and then adjacent to that angle is A. Now what makes this rule a bit different from Pythagoras is if we were instead looking at that angle, which I'm going to call alpha, then this side would become O, that side would become A, but the hypotenuse would stay as H. And what we learnt real quickly in our measurement lesson is we had these three ratios. So we looked at the sine of the angle, the cos of the angle, and the tan of the angle. And what we got to eventually was the sine of the angle is the relationship between the opposite and the hypotenuse sides, cos is the relationship between the adjacent and the hypotenuse, and tan the relationship between the opposite and the adjacent. So those are our three rules that we need to know and learn for trigonometry, and we've got a really nice simple way that we can use to help us remember this rule. So we use an acronym. Sohcahtoa. So the way that works, we've got S for sine, opposite hypotenuse, cos adjacent hypotenuse, tan opposite adjacent. So if you can remember Sohcahtoa, write that down at the top of your test paper. You should be pretty sweet for your right angled triangles. So we will have a look at a quick example of how we can use Sohcahtoa to help us with a triangle. So we've got a right angled triangle here. I've labelled an angle with 40 degrees. I've labelled the hypotenuse side as 10 centimeters, and I've labelled one of the sides as X, and that's the one that we want to try and find. So the way we use Sohcahtoa is we start by labelling a triangle. So we can start by labelling the H because that's always easy. I always go with O next. I find that the easiest one to start with, looking at the angle I'm given, which is this one, the 40 degrees. Opposite this angle is my O, which leaves the X as the A. Now we've got to decide which of the three rules we're going to use. And the way we do that, we're always only going to have two pieces of information. We don't have any information there. So we need to look at the rule that uses A and H, which is our cos rule. So we write out our cos rule, cos theta equals A over H. Then we substitute the triangle information into a rule. So we've got three pieces of information, an X, a 40 and a 10, that we're going to substitute into this rule. So our theta becomes 40 degrees, our A becomes X, and our H becomes 10. So now we've just got a simple equation to solve. Just like in algebra, we're dividing by 10, so we times both sides by 10, which leaves us with X equals cos 40 degrees times 10. And that we put into our calculator. Remember in class we looked at making sure our calculator is in degrees mode. That's really, really important. If you haven't figured that out, please make sure you see me in class and we need to get that sorted as soon as possible. So once we're in degrees mode, cos 40 times 10 equals 7.66, which you can't really see on that screen unfortunately. And we always want to put in our rounding statement there. So what I'm going to get you to do now is have a look at your My Maths lesson, which I have set for you. I'm going to take you to there right now just to show you the first part of it. As you can see, you've got 6 triangles there to work out, and I want you to work these out in your maths book, because I don't want you just pressing buttons on a calculator and putting the answers in. You need to get used to showing the working. So I'm going to go through that first one with you and then leave the rest for you to do before you come back to class tomorrow. So when we look at that first triangle we're given, we've got an angle of 28 degrees, hypotenuse of 5 centimeters, and another side which is labelled X. So what I would expect you to do is copy it down like this into your book, label the triangle like we just talked about, so that would be our O, A and H. Our rule that uses O and H is the sine rule. Sine theta equals O over H. Substitute into the rule. Sine 28 degrees equals X over 5. X equals sine 28 degrees times 5, which we will put into our calculator. Calculators run out of batteries, so we'll use a backup. Sine 28 times 5, and there we get the answer of 2.34. I believe the question wants us to do it to 1 decimal place. So once you've worked it out in your book, you'll go back to here, put in your answer, 2.3, and you check it, you'll obviously be correct. So that is Sohcahtoa. It's a really important rule that we need to make sure that you know. So I'll get you to stop this video now and go into your My Maths and practice with the next 5 examples. Good luck.